Good morning, everyone. I am Sweta Sarangi, and in your previous session, we have studied about the stopping side distance. Okay, so in the last class, we have studied that how we calculate stopping side distance. So, stopping side distance will be leg distance plus braking distance, and given by SSD equals to V into T plus V square upon 2GF. Okay. So what is V? V is design speed in kilometer per hour or meter per second. T is our reaction time. G refers to acceleration due to gravity. F is equals to coefficient of friction. So when there is an ascending gradient of say plus n%, the component of gravity adds to braking action and hence braking distance is decreased. The component of gravity acting parallel to the surface, which adds to the braking force, is equal to W sine alpha is nearly equals to W tan alpha is equals to Wn by 100. Okay. So equating kinetic energy and work done, Fw plus Wn by 100 into L equals to Wv square by 2g. So the formula will be, when we are considering the gradients, L equals to V square upon 2G whole into F plus N by 100, because here we are considering the gradient, the slope in percentage. That is why here we can say N into 1 by 100 or N by 100. If we are considering a descending gradient, then the formula will be L equals to V square by 2G whole into F minus N by 100. Okay. So next is overtaking side distance, OSD. The overtaking side distance is the minimum distance open to the vision of of the driver of a vehicle intending to overtake the slow vehicle ahead safely against the traffic in the opposite direction. The overtaking side distance or passing side distance is measured along the center line of the road over which a driver with his eye level 1.2 meter or 120 centimeter above the road surface can see the top of an object 1.2 meter above the road surface. Okay. So the factors that affect the OSD are: first is velocity of the overtaking vehicle. Next is overtaken vehicle and the vehicle coming in the opposite direction. Second one is spacing between vehicles, which in turn depends on the speed, skill and reaction time of the driver, rate of acceleration of overtaking vehicle, and the last one is gradient of the road. So these are the factors on which our OSD depends. So the dynamics of the overtaking operation is given in the figure, which is a time-space diagram. The x-axis denotes the time and y-axis shows the distance traveled by the vehicle. The trajectory of the slow-moving vehicle B is shown as a straight line, which indicates that it is traveling at a constant speed. A fast-moving vehicle A is traveling behind the vehicle B. The trajectory of the vehicle is shown initially with a steeper slope. The dotted line indicates the path of the vehicle A if B was absent. The vehicle A slows down to follow the vehicle B as shown in the figure with same slope from 0 to T0 to T1. Then it overtakes the vehicle B and occupies the left lane at time T3. So the time duration T, capital T equals to T3 minus T1 is the actual duration of the overtaking operation. So the snapshots of the road at time T0, T1 and T3 are shown on the left side of the figure. From the figure 1, the overtaking side distance consists of three parts. One is D1, the distance traveled by the overtaking vehicle. A, during the reaction time T equals to T1 minus T0. Second one is D2, the distance traveled by the vehicle during the actual overtaking operation T equals to T3 minus T1. And the third one is D3, is the distance traveled by a oncoming vehicle C during the overtaking operation T. So therefore, OSD equals to D1 plus D2 plus D3. It is assumed that the vehicle A is forced to reduce its speed to VV, the speed of the slow moving vehicle B, and travels behind it during the reaction time T of the driver. So D1 is given by D1 equals to VV into T. Then the vehicle A starts to accelerate, shift the lane, overtake, and shift back to the original lane. The vehicle A maintains a spacing S before and after overtaking. So the spacing S in M is given by S equals to 0.7 VV plus 6. Let T be the duration of actual overtaking. The distance traveled by B during the overtaking operations is 2S plus VV into T. So the D2 will be 2S plus VV into root over of 4S minus A. So the distance traveled by the vehicle C moving at design speed V meter per second during overtaking operation is given by D3 equals to V into capital T. Okay. So the formula or the length of OST equals to D1 plus D2 plus D3. In this way, we can find the distance of overtaking side distance or length of overtaking side distance. Next is PIEV theory. This is the most important factor. According to PIEV theory, that means P means perception, I means intellection, E for emotion, and V for volition. So this theory developed by some prominent traffic engineers. The total reaction time of the driver is composed of the following four elements. First one is P, that is perception time. It is the time required for the sensation received by the eyes or ears to be transmitted to the brain through the nervous system and spinal cord. In other words, it indicates the time required to perceive an object or situation. Next is intellection time. It is required for understanding the problem or situation. Third one is emotion time. The emotion time in which is passed during emotional sensation and disturbances such as fear, anger, etc. And the last one is volition time. It is the final time or it is the time taken for the final action. Okay, here we can see this is the spinal cord, this is response stimulus, that is our IE, that is intellection and emotion. Okay, that is our perception, intellection, emotion, and volition. Curves, railways, etc., and also in canals to bring about the gradual change of direction. They are also used in vertical plane at all changes of grade to avoid the abrupt change of grade. So in order to achieve a gradual change of direction at the intersection of a straight alignment either in horizontal or vertical plane, curves are provided. The curves are provided due to following reasons: due to topography of the area, to provide highway facilities to a particular locality, for avoiding existing religious, monumental and other valuable property, for making use of the existing right of way. So there are two types of curve. First one is horizontal curve and second one is our vertical curve. So what is horizontal curve? It is this type of curve are provided to change the direction or alignment of road, or we can say this type of curve is used to change in direction. Horizontal curve are circular curves or circular arcs. The sharpness of a curve increases, the radius is decreased, which make it risky and dangerous. So there are three types of horizontal curve. First one is circular, second one is compound, and third one is reverse curve. So we can say simple curve, compound curve, reverse curve, and spiral curve. Transition or spiral curve. A curve that has a varying radius. It is provided with a simple curve and between the simple curves in a compound curve. While turning a vehicle is exposed to two forces. The first force which attracts the vehicle towards the ground is gravity. The second is centripetal force, which is an external force required to keep the vehicle on a curved path. At any velocity, the centripetal force would be greater for a tighter turn, smaller radius than a broader one, larger radius. Thus, the vehicle would have to make a very wide circle in order to negotiate a turn. Next one is our vertical curve. Vertical curves are provided to change the slope in the road and may or may not be symmetrical. They are parabolic and not circular like horizontal curve. Identifying the proper grade and the safe passing side distance is the main design criterion of the vertical curve. Crest vertical curve, the length should be enough to provide safe stopping side distance. And in sag vertical curve, the length is important as it influences the factors such as headlight, side distance, rider comfort, and drainage requirements. So vertical curves are of two types: sag curve and summit curve. And next we will continue in the next class. Okay, thank you.